Okay, so here we have some scatter plots, right? So how are these different than the ones we looked at previously? Or how are they the same? There's one going up, one going down.
One has letters.
One has letters on. Okay, that's just part of the picture. Some we'll use later on. What's special about these? What's different about these? Rebecca, take your phone off.
Always like doesn't go straight up. Like,
Yovanique, just what'd you say? It curved. Which one curves? Top left, bottom left, or the one on the right?
top.
The top one, it kind of curves. So we've talked. I probably guys a little bit. The line is the best fit, right? Some of you might be imagining a line that looks like this, right?
Yeah.
Some of you might be imagining it. What's another way you could draw this line? They use words. The camera has a hard time picking up your fingers back there. Curve, how?
Draw like a scenario.
Start here and curve up. Well, that's different. Because the ones we just talked about were linear. That blue line, is that linear?
Yep.
No, it's not linear, right? It's a non-linear line. Interesting. What about this one? Is this one? What can we say with this one? Is it linear?
So messed up.
It's all messed up. No, it's a dinosaur. It's a dinosaur eating a mouse. Okay. Is this one linear?
No.
No. You sure? Where does it start?
I don't know.
It like goes down, curves-ish.
Curved-ish. Because I think I'd see a line. I think I see a line going like this. Does that make sense? Do you think that fits? Or do you think I should do something that's curved? So you might think I want to do something that's curved, but I think that curve is going to leave it off these guys, right?
Yeah.
So maybe that one's linear. What about the one on the right? It's a squid. Parabola. A parabola goes like this.
Well, the other thing then.
It goes like that?
No, like the one.
Like exponential decay?
I don't know what it's called.
Butterfly? Volcano?
Like a sideways volcano.
A sideways volcano?
Yeah.
So you're thinking we have like a curve here and a curve here?
Yeah. Like more like.
I've never seen a graph that looks like that.
I have.
It'll fail something called the vertical line test, which we'll talk about later. It's not a function because it hits the vertical line twice. We'll talk about that later, though. But it'll fail that. It won't work.
Well,
Okay. Where would this one be?
Nothing.
I think Rebecca's on the right track. The line of best fit would probably be right down the middle. Now there's something going on here that might not be useful or used to. It is useful. We're just not used to it. This right here is a curved one. You guys picked up on that. This is a curved relationship, right? Is it strong or weak? Strong because these points are all pretty close together, right? Right? But it has a curved relationship. So it's not straight. It's not straight. It's an L word I'm looking for. It's not linear. Right? It's a non-linear relationship. And that's okay. Is this one linear? Yeah. I think this one and this one, Maddie, have a lot in common. You're probably saying they do not. This one looks like a funnel. That one just looks like a point spread all over the place. I think they have some things in common. Okay. If I look at just the left side of this one, is that a strong relationship or weak relationship? Kind of strong, right? If I look at just the right side of this one, or just the left side, sorry, man, all over the place. Okay? Strong or weak? Weaker, right? What about over here? Let's do the same thing. Let's look at the left side. Strong or weak? Weak. Let's look at the right side. Strong. So what's happening to the correlation? It's getting stronger. Could it be possible that it gets weaker too? Yeah. This graph could be flipped around and it could be getting weaker as we go increase our x. So what's happening instead of C word there? Changing. The correlation coefficient, the R value for these ones are changing. Here we have an R value that's close to 0, right? As we go this way, the points get closer and closer to the line, which makes the R value closer to -1 in this case, but makes it stronger, right? Send me over here. Points far away, points get closer. Okay. These three graphs show some interesting situations about scatterplots that we're going to discuss today. Any questions before we move on? Excuse me. All right. Actually, to discuss these, we're going to look at example 2 from our yesterday. So let's see if we can find it. Is this example 2? Nope, that's not example 2. There we go. There's example 2. Okay. We'll zoom in a bit. That's funny. Well, we were clicking on the QuickTime video. Why is it not reacting? Okay. Now these lines are these scatter plots. Are they linear or nonlinear? Linear. Okay. 0, 1 of those two. All right. Today we're learning still Unit 4. This is Lesson 1, still Investigation 2. And we're going to talk about clouds. Okay, some of you probably think, whoa, we did that in 8th grade. Cumulus Stratus, all that stuff. Did you do it in 8th grade? Yeah, maybe, I don't know. 7th grade, okay. You're thinking we did this in middle school. We talked about clouds then, but these are not the same clouds. Okay? The clouds we're talking about are math clouds. Okay, not weatherman clouds. Right? The clouds we're talking about are a shape that encompass most of or all the points in a scatter plot. So a cloud is a shape that encloses most of or all the points in a scatter plot. So the shape that encloses most of or all the points in a scatter plot. Be nice if I had it like on a robot and I could like turn the camera on my own. Maybe lots of extra credit, you can build that. A panning and a pitching robot that'll change my camera on. No? Jessica, you want to do that? Okay. All right. So it's a shape that encloses most of or all the points in a scatter plot. Right? So the shape of the cloud will tell us some interesting information about the scatter plot itself. So these first 4 pictures, these are ones that you have on your examples. These are ones that you have on your examples. Right? Now, if I was going to draw a shape that encloses all of these points, what might it look like? A shape that goes around all these points, what might it look like? A circle. Kind of circular, right? An oval. Good, there's the word I'm looking for. Okay. If I enclose all of these with a shape, okay, that's an oval. Right? Another math term for that is an ellipse. Now, which one is stronger again, the left one or the right one?
Right. Left.
The left one, right? The left one, correct?
Yep. Yeah.
This one is stronger. So, if I draw a shape around this one, is it still going to be oval? But how will it be different? Let's draw and find it. Bigger.
The one that left, I mean the right bigger.
It's more like a watermelon, right?
Yeah.
This one's kind of like a pickle, that one's kind of like a watermelon, right? Okay. The oval gets a little bigger, right? Now what about down here? Which one's stronger, left or right? Left is stronger. Okay? So if I draw ovals for these ones, will they look just like those ones? Will the oval look exactly the same as this one? No, what's going to happen? It's going to tilt the other way, right? Because it's going to be a negative. Now, this guy right here, I'll circle it in I'll box it. This guy right here might be something special for that set of data. Does anyone know what that guy might be? An outlier, an outsider. Okay, an outlier.
Special
Like the
one.
person who sits by himself at lunchtime, right? Okay. No, it's an outlier, right? It's lying outside the data set. If I include that one, that's fine, but my cloud doesn't always have to include my outliers. Right? So there I have what shape is that again?
Pickle.
Oval. Okay. Here I have
It actually looks like a pickle too.
it has little spots on it.
Yeah.
Okay. There I have another oval. Okay. Now this one doesn't have any clear outliers because this one's just kind of off by itself. There's no one that's kind of off by themselves here. Right? They're all fairly close to another point, aren't they? Okay. So this oval, is it wider or narrow? It's wider than this one. Okay? Because this relationship is strong or weak? Weak. Okay? This relationship is stronger, so it's more narrow. So we've been focused on that R value, right? That correlation coefficient. We've done a little bit of work with that. We've calculated one before, right? The R value is difficult to calculate, right? You can't just say, oh, my R value here is 35. That won't make sense anyway. You can't say my R value here is 0.35. Okay? I can't just say that, can I? Now, when we do this example, we predicted some R values, right? We said this one might be 0.7, so this one's got to be 0.6, but we didn't actually calculate. Now what these ovals do is they kind of give us a visual representation of what that R value, or how those R values relate to each other. Right? We know since this oval is narrower, this R value will be closer to 1. This oval is wider, its R value will be closer to 0. Okay? So the width of the oval tells us how close the points are to each other, how close they are to that relationship. Right? So, clouds. The first type of cloud we're going to talk about is a Cumulus Stratus. Just joking. Oval or ellipse cloud. Real quick funny story. My daughter has those little wooden puzzles, right? One of them has they said his name is a diamond. It's not a diamond. It's a square that they flipped the other, that they rotated 90 degrees. So I rewrote on their square. So she has 2 squares on hers. They have one that says oval. I crossed it out and said ellipse. Okay? Because that's the math word for oval. You guys are all used to oval. But oval is really ellipse. And not take the fun out of it. I took the dumb out of it. Took the dumb out of that stuff. They have 2 triangles on there. They call them both triangles. I said, no, this one's isosceles, that one's equilateral. I changed them. Okay? She's smarter because of it. She can't really say equilateral, but we're working on it. Right? So, oval ellipse. All right? An oval or ellipse cloud tells us what type of relationship. What type of relationship is there? It could be strong or weak, but these are all linear. There you go. They're all linear. If I have an oval or ellipse-shaped cloud, then we have a linear relationship. What does narrow oval mean? Means we have a strong relationship. What a wide oval mean? What do you mean? Weak. So remember, we have a strong relationship. Those are R values that are like 1, 0.9, 0.8. Interesting comma. Okay. -1, -0.9, -0.8. Right? 0.7. Right? The decimals that are close to 1. If I have a wide oval, we have a weak relationship, right? That means the R's are like 0.2, 0.3, 0.4, okay? Or -0.2, -0.3, -0.4, okay? 0.5 and 6 and 7 will fall in between those. Won't be as wide as the wide oval, won't be as narrow as the narrow oval. Now, what is the widest oval you can think of? What are we leaving out here? A circle. What's a circle? It's an oval, because ovals usually are really wide on one side, really short on the other side, right?
Yeah.
So if I make this oval so wide that it is wide as it is long, what am I going to have? A circle. So what type of R value would a circle have? Oh, it would not have 1.
0.
0. It's a no relationship. Okay. So if we have a circle cloud, that means no relationship. So you're probably thinking a circle cloud. What do you mean? Okay. Let's say I have 4 dots. What type of relationship do those 4 dots indicate? Is it positive? Is it negative?
No.
We don't know. Okay. But if I draw a cloud around these, what is it? A circle. Because there's no relationship there. Right? There's no relationship. Right? The closer you are to 0, the more circular the cloud will get. It's like -0.1, negative 0.1, 0. Those are have your no relationship R values. So R is close to 0. So does that make sense? Well, any questions? Okay.
What about like the strong and weak relationship thing?
Yep.
What about 0.1?
0.1. 0.1 will be closer to the circle. Okay. 0.5 won't be as wide as the wide ovals, won't be as narrow. Okay. Remember, it's kind of like that hot sauce ranking we talked about yesterday, right? 0.5 is kind of, is it the hottest? No. Is it the mildest? No. It's just kind of in the middle. Okay. The ovals are more or less for comparing relationships. Okay. Because this oval is narrower than that one, we know this one is stronger. Okay. I can't say this R value is 0.5 because the oval looks like this. Okay, but I can approximate. Right. If my oval is really narrow, then it's probably like a 0.9. Right? Like if my oval looks like this. Okay, probably like a 0.9 or something. Right? Does that make sense?
Yeah.
Okay. But it's more an approximation. It's more a comparison tool for which correlation is stronger. Okay? Does that help?
Yeah.
Okay. Any other questions? Let's go back to this one. Here's the same ones we talked about earlier, right? Hey, got that one in the oval. But is that oval the best fit for that one? No. The oval might fit this one. Right? The oval might fit this one. I could draw an oval like this. Right? Kind of fits, doesn't it? Right? The fat oval, so big R, or strong or weak correlation? Weak correlation. What about this one? The oval kind of fits it. We might have some more of those O words. What was that again? Outliers, right? But is an oval really the best fit here? No. It's like when you borrow your friend's shoe. They just don't fit just right. Okay. So, what might fit this one? An oval or something else? A circle? I don't think a circle. A rectangle? We're going to play Pictionary here. What is that? Something, okay, a bugle? Make your breath smell terrible? Yeah. Okay. What is it? A banana! Good job. We're good at Pictionary. We play Pictionary, Yovanique's on my team. Okay. An eggplant? We call it eggplant. There's a little stem, right? The eggplant. Okay. But either way, eggplant, banana, cucumber, they're all having a little bit of a curve to them. Okay? So I actually call this a banana cloud. Your book calls it a curved oval, but where's the fun in a curved oval? Right? I call it a banana cloud. We can also call it a J cloud. Right? But how is this curved oval, or this banana cloud, different from the actual oval? Okay, it's skinnier, so this relationship is stronger, okay? What type of function might this be? If I was going to draw a line of best fit, what might it be? Well, this would be straight or curved? This would be straight, so it is linear. What would this one be? Curved, so it is nonlinear, right? And that's the big difference. If I have a curved cloud like this, a banana cloud or a J cloud, it is nonlinear. Is that what they're saying on Facebook, Joanna? No? You're too cool for Facebook, right? That's Twitter, wasn't it? Okay. So, if I have a curved cloud, it is nonlinear. If I have a just an oval cloud, it is linear. Okay. Understand the difference?
Yep.
And the width can still tell us our value. We can compare these relationships. This one is stronger than that one because this one isn't as wide. Does that make sense? Does that make sense? Over here, we'll take some notes about banana clouds. Every time I spell banana, I gotta sing that song. There you go. Okay. A banana cloud. All right. And you find out J. Why'd you put a J in there? Because a banana kind of looks like a J. Right? A very gradual J. Okay. And the book calls them J clouds. So that's why I kind of put it in there. So banana clouds, J clouds, whatever you want to call it. Now, if I have a narrow banana cloud, is that going to have a strong correlation or a weak correlation? Strong correlation. So a narrow banana or a narrow J. Strong correlation, strong relationship. Kind of using those interchangeably. And if I have a wider banana, what's that going to have? Weak correlation. So a narrow banana might look like that. Looks like a pick. A wider banana might look like that. Like a bean. Right? Now, if they have a correlation, would this be positive or negative? What do you think? Negative. That'd be a negative correlation because we're decreasing, right? This one would be a positive correlation because we're increasing. As x goes up, y goes up. As x goes up, y goes down. Okay. So we can still have positive and negative with banana clouds. Okay. Does that make sense? Now, if we get a really, really, really wide banana, okay, or a really, really weak correlation that might be nonlinear, it's probably still going to have a circular shape. Okay, because if I keep making this banana wider and wider and wider and wider, eventually it's just going to become pretty much circular. Any questions about that? Listen, any questions? No? Okay. What about this one? Where does this one fit? Oval, banana, what is it? Nothing. It's a triangle cloud, right?
Yeah.
Okay. It's a funnel cloud. Oh, don't say it too loud. You might think we have a tornado coming around. Right? Yeah, it kind of looks funny, doesn't it? Right? Well, let's look at this kind of piecewise. I know we talked about this a little bit earlier. If I just look over here, kind of have a narrow banana or a narrow oval, whichever you want to call it, right? If I look over here, I have a wider oval, wider banana, right? Okay. So over here, do we have a strong correlation or weak correlation? Weak. Over here? Strong. So we have what's happening here? What's happening to strength?
Relationship.
There's a relationship here. It's getting stronger. So we have what's called a varying strength. Or a varying correlation. So you can also have clouds that have a varying strength or correlation. Varying strength clouds are typically wider on one end and narrower on the other. Okay? Notice I could reflect it and look at the other way. It could go from strong to weak, right? Or weak to strong, but it has a varying strength. Okay? That means the R value, is it constant or does it change? Change, right? So the R value changes. Okay. R changes. That's the best way to think, the best way to look at it is kind of an extreme case. Kind of what you call it? Yeah, it kind of does look like a corn dog, doesn't it? Okay. Because if I were to draw an oval here, we'd have a narrow oval right here, right? We'd have a wider oval right here, right? And there's kind of like a seam right there, right? So we go from a weaker correlation to a stronger correlation. Does that make sense? Yeah. Are there any questions about that? Any questions? No. So a varying strength cloud is now called a corn dog plot? How many corn dogs are consumed? No. Spatula. Any questions?